Hi, it's Kevin Lobates here. So I wanted to go a bit more into the beacon chain system that's being proposed for Ethereum in order to provide truly random numbers within a blockchain and assist with things such as gambling, provably fair games, and of course the proof of stake system. So the beacon chain consists of two parts. The first part, I think I touched on briefly, is the Aranda, which is a mechanism whereby parties can create an initial random number. And the way that's going to work in Ethereum is that 128 parties are selected to put forward a random number. And these, or rather they don't put forward the random number, they put forward a hash of the random number first, and then in sequence they reveal these random numbers, and they are what is called XORed together, which is a way of sort of combining them, adding them up, sort of. I won't go into the specifics here, it's not too complicated, so go and look up XOR if you really want to know. The idea here is that if even just one of the 128 is honest and the rest are dishonest, then you still end up with a random number. So the probability of you not getting a random number should be very, very low. There is, however, one problem with this system, which is that parties may choose not to reveal their random number in order to be added up in this XORing activity. And this is particularly relevant for the last party. The last party can look at the random number that's been generated so far and then look what happens if their choice is added to it and decide which one they prefer, and on the basis of that decide whether or not to reveal their last number. But for all the ones beforehand, it really doesn't matter whether they do or don't reveal their number, as long as the honest one does. So that's the Aranda part, and it does have this weakness that it can be gamed by the last of the 128 participants in the system. So then what they've done to get around this is there is then a second phase, and this uses something called a verifiable delay function. And it's basically a pseudo-random number generator, and it takes the random number as a seed. And the way that they get around this final party trying to game the system by either revealing or not revealing their number, and therefore getting to pick between two different random numbers in the system, is that you feed the output of the Randao into the VDF, and then the VDF requires this calculation. It's called modular multiplication, and modular multiplication takes a bit of time, and you have to do this a lot of times in order for the verifiable delay function to finish. And because the final party can't know what the output of the VDF is going to be by pre-calculating it, because it takes too long, they have to go ahead and reveal their number, create the final seed for the VDF, and the VDF then churns away for this period of time, and then you get your true random number out at the end. So that second bit is to overcome this bias. And the thing about the VDF is that it can be done quicker with dedicated hardware than it can be done with a traditional computer, but not much faster. And the VDF that they've selected is set up in such a way that it's expected that people are not going to be able to crack it and be able to game the system by working out what two possible outcomes there are at the end, and thereby selecting one that is better for them. So the Ethereum Foundation is going to be releasing some reference hardware for the VDF, and in fact they're talking about building about 5,000 of these rigs and giving them out to various interested parties in order to be able to run this as a service. And this is going to incur a cost of about 5 million for the foundation, and then there's also this figure of about another 20 million in terms of the research and development costs in order to build the software that implements this whole system. So this is what I meant in my previous video, that the process of building this random number generator in Ethereum, it's not coming cheap. It should still, of course, be levels of magnitude less expensive than the current proof of work system when you look at all the mining rigs that are out there churning away to currently secure the Ethereum chain with proof of work, but it's not free. And in particular, given this cost, it's going to make it hard for other parties to build parallel systems, different implementations of the same protocol. So I think that's a problem too. But anyway, I mentioned in a previous video that I also have this belief that there's a fundamental economic rule that says that no matter how you try to get round the cost of securing a blockchain, it will still end up costing you about 60 to 90% of the value of the cryptocurrency that's generated at the end. And that's something I'll go into later this week, hopefully, if I can get my thoughts together on that. Anyway, videos seem to be getting a bit longer these days. I'm going to have to work on keeping them a bit shorter. Hope you found this one interesting, and see you in the next video soon. Bye for now.